And let me share my screen. And let me open the screen that I want. Okay, today we're going to look a little bit more at descriptive statistics. We're going to start looking at measures of central tendency. Homework 14 is on the representing data graphically and also on those surveying techniques. It's due on Monday. Homework 15 is on those measures of central tendency, and hopefully we will get through a good chunk of those today. I'm sorry, by Monday, I meant Tuesday, and those will be due on Thursday. There will be a brief quiz on Monday. It'll probably be available after class, and it'll be due by the end of the day on Tuesday. It'll be on representing data graphically. Does anybody have questions on anything that we've worked on thus far? And also, can you guys hear me okay?
Yep.
Okay, all right. Some of the other classes were complaining yesterday. If I remember correctly, we had left off with making a histogram. And we had said with the histogram, it's a bar graph. The height of the bars is the frequency. The bars must be equal widths. If we're looking at single values, they're centered over the value and the bars must touch. I'd like to look at one more histogram, and that's a histogram for grouped data. And so in terms of looking at grouped data, I want to make a histogram for the data that we had for birth dates. And I'd like to recycle the frequency distribution that we had. And so we had dates and frequency. And we had grouped them 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, 26 to 30, and 31 to 35. And our corresponding frequencies going down were 1, 2, 3, 4, 2, 2, 1. When I look at that histogram for grouped data, my preference is to label the horizontal axis with the class. Usually I use the upper limits. And that's just my personal preference. And so as I go through and look at this, the title would be birth dates. The vertical axis would be our frequency. The horizontal axis would be our dates. We're going to start at 0, and then we're going to label it with those limits: 5, 10, 15, 20, 25, 30, 35. And our highest frequency is 4. So I'm going to have that axis go up to 4. And so there was one person between 0 and 5. So in that region, I'll have a bar of height 1. 2 people, 6 to 10. 3 people, 11 to 15. 4 people, 16 to 20. 2 people, 20 to 25. 2 people, 26 to 30. And 1 person over 30. And I think labeling the axis like that makes it look a little bit neater. The alternate way that you sometimes see it is for that horizontal axis to have underneath it instead 1 through 5, 6 through 10, 11 through 15, and so on. I think just labeling it with the lower limits makes it look a little bit neater. But again, it's a matter of personal preference. I think because your tests and quizzes will be in my labs, rather than having to draw your own, you will most likely be pulling out multiple choice, which is the correct graph for this data. Okay, any questions on that? Hearing none. Next place we're going to go is something that's called a frequency polygon. And a frequency polygon is similar to a histogram. The horizontal axis is going to have the data values. The vertical axis is going to be the frequency. We have to make sure we label everything. But this is a broken line graph. And in this broken line graph, it's important that we start and end on the axes. And so for an example, let's look at, again, that data that we had for shoe sizes in class. And in order to do that, I want to look at our frequency distribution for shoe sizes. And I copied down the information that we had last time. 5, there was 1. 6, there was none. 7, there were 2. 8, there was 1. 9, there were 5. 10, there were 3. There were no 11s. 12, there were 3. 13, there was 1. And 14, there was 1. So just like before, this horizontal axis is going to be my data and my sizes. This vertical axis is going to be my frequency, or we could again call it number of people. This we're going to count up from 0, and the highest we need is 5. Now, I'm not going to count all the way up from 0. So again, I'm going to put a break in my axis. And again, that's only there because I'm lazy and I don't want to count all the way up from 0. Since my lowest value is 5, and I have to start on the axis, my first is going to be 1 lower than the lowest value. And then I'll have my 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then I want to also go 1 higher than my highest value. And we had said that we want to start and end on the axis. And that's why I want to go 1 lower and 1 higher with the histogram, we made bars whose height was the frequency. Instead, with a broken line graph, we're going to plot points. If I want to think of points as ordered pair, my point is going to be my data value with its corresponding frequency. And so nobody had a size 4, so I'm going to plot that point 4, 0. One person had a size 5, so above the 5, I'm going to put a point at height of 1, pardon me. Nobody had a 6, so the point above 6 is going to be at 0. 2 people had a 7, so the point above 7 is going to go to 2. One person had an 8, so we'll have a point at 8, 1. 5 people had a size 9, so I'll have a point at 9, 5. 3 people had a size 10, so I'll have a point at 10, 3. Nobody had an 11. I'm back down to 0. 3 people had a 12. One person had a 13. One person had a 14. And again, we want to end on the axis. We're going to make note of the fact that nobody had a 15. And now that I've got those points, I'm going to just go and play dot to dot, connecting them. And when I connect them, I get kind of like this jagged line, which is what's called a broken line graph. We have all sorts of little line segments strung together. I'm beginning on the axis, I'm ending on the axis. In my mind, I like to compare this to our histogram. If I were to, I'm going to just for a minute put in highlighter underneath what the histogram looked like. And you see, it's like taking the histogram and putting a dot in the middle of each bar and connecting them. So it's somewhat similar to the histogram, just a different shape. Usually in class, what I would do if we were at the dry erase board is I would overlay the frequency polygon on the histogram to show what I tried to show here with highlighter. And again, with each of these displays of data, you have to be able to do two things. One, you have to be able to make the display given the data. But then the other thing you have to be able to do is, if I were given the graph, work backwards to get the data. Given that broken line graph, would everybody be able to recreate the data values? Any questions? Is everybody all right if I turn the page? And in turning, go ahead. In turning the page, we're going to make a big leap of faith and go into that second section of chapter 12. We're going to start looking at measures of central tendency. And measures of central tendency are what it sounds like. They're descriptions of the middle of the data. Some ways you can almost look at them as types, different kinds of average. They all describe the middle, but in a different way. And they all have very specific places where they're more useful than the others. So they all describe the center in different ways. And each is useful for something different. And hopefully we'll look at examples of when each is useful. They all begin with an M. Most of them begin with an M. I think they all begin with an M. And so they kind of make me think of my dad, because when we were little kids, he used to fix everything with 3M tape. So, which you probably, I don't think anybody ever refers to 3M tape anymore, but dating myself here. First one that we're going to look at is the mean. Has anybody heard of the mean of a set of values?
Yes.
Yeah. The mean is also referred to as the arithmetic average. In order to find the mean or the average of a set of values, what do?
You add them all together, and then isn't it that you divide all the numbers by the number of numbers?
So we total the values and we divide by the number of values. Beautiful. Let's look at a little bit of notation before we look at examples. Usually the mean is written as an X with a line over it, and it's called X bar. Has anybody ever seen this uppercase Greek letter sigma in math?
Yeah, it's the sum on the in Word.
It's
I mean,
the
in
sum.
Excel.
Yeah, and that's what it means. It means
Yeah.
sum. The sigma means sum. We're going to have X sub n be our data values. And I'm not sure how familiar you folks are with subscripted numbers. That would be like X1, X2, X3, up to however many I have. The subscript just represents which value it is. So we're saying that all the data is X. X1 is the first number. X2 is the second, and so on. We want to use the variable X to represent our random, numbers in our data set. But then, to differentiate between which is the first value, which is the second value, and so on, because they usually our data values are not all the same. We put that subscript in there. N is going to be referred to as the sample size. And the sample size is going to tell us the number of values that we have. And so before, where I said the mean is equal to the sum of the, what word did we use? The total of the values. Let's use the same wording. Over the number of values. People like me who don't like to write and struggle with that whole spelling thing would say that X bar, that's the mean, is equal to say sum, we're going to use that uppercase sigma, and we're adding our data values, so that's sigma X sub n over the number of values n. And these two things say exactly the same thing. So I'd like to, for an example, look at the number of siblings that students in class have. And I'd like to divide the class into two groups. So we'll have group 1 and we'll have group 2. And usually when I do this, something truly wonderful happens with the randomness of the way the groups are made, but we'll see. So just for a minute, I'm going to stop sharing my screen and make my little set of notes real tiny at the bottom. As I look at this, I have two distinct halves to the class. So for the people that are in the little boxes on my right, tell me how many siblings you have. Don't include yourself. Tell me how many total brothers and sisters you have. Debbie? I didn't hear you, hon. You have
Sorry, I was muted. 4.
4. Okay. Josh?
3.
Michaela?
2.
Connor?
Oh, what was it? Sorry.
How many total brothers and sisters do you have?
Oh, 2. Sorry.
Robert?
1.
Michael? Michael, are you there?
None. Sorry,
None?
I keep myself muted. It takes me a minute to unmute.
No, that's okay. I'm just happy that you're still there. I worry about sometimes, not so much in this class, but in some of my other classes, I've noticed that people show up for the attendance and then just leave Zoom on and don't stick around for class, and that worries me greatly. Zach K, how many siblings?
4.
Okay. And Jackson, how many brothers or sisters do you have?
1.
1. Okay. And now, oops. I'm trying to move things around. Other side of the room. Gina, how many brothers and sisters do you have?
4.
4.
Mm-hmm.
Colton,
3.
Zach B. Zach B, are you there? Zach? Well, Madeline,
5.
Demia? Demaya, I'm sorry, I said it wrong again. Oh my God, yell at me. Demaya, how many? Demaya, are you there?
She said that her voice isn't working.
Can she type in the number of siblings she has?
Oh, sorry, that was Zach that said that, not Demaya.
Okay, can Zach type in the number of siblings?
Yeah, he said
He
2.
has 2.
2? Okay, Janae,
5.
David,
2.
Chris,
12.
12?
Yeah.
I love you because I was looking for one person with a large family to prove a point. But wow, I feel sorry for your parents. Although they're blessed because they have
I'm the
so many-
only one for the both of them though.
Oh, okay. All right. All right.
Yeah.
Okay. And Caitlin?
3.
3. Okay. Now I'm going to share my screen again. And oops, I gotta center and make it larger. And so for group one, when I want to find the mean, in order to find the mean, I want to add up the numbers and divide by how many. So adding the numbers gives me 4 plus 3 plus 2 plus 2 plus 1 plus 0 plus 4 plus 1. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to divide that by 8. And so what does that give me? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 divided by 8, which would give me 2 and an eighth. And while we've got that number there,
Wait, you went really fast. Was that just for group one?
that was just group one.
Okay.
Okay. And before we go any further, I want to talk about a rounding rule. No matter what my data represented, my values are all whole numbers here, right? Going back up to the average for group one. And to see my result as a decimal worked out to the thousandth place, doesn't it look like my data values, which were much more exact than whole numbers? So if you're not told where to round to, you're supposed to round to just one place value to the right of the original data. So we would actually round that to just 2.1. Now, first question I want to ask is, does anybody have 2.1 siblings? I don't think anybody in the class referred to any of their siblings as being a fraction of a person. I guess that would be kind of mean, although everybody's got one of those siblings, right? No, I didn't say that. But notice that the mean does not have to be one of your data values. And again, we're only going to round one decimal place past the original data. For group two, if I look to find the mean, I'm going to add those values and divide by how many. So that would be 4 plus 3 plus 5 plus 2 plus 5 plus 2 plus 12 plus 3. And we're going to divide by 1, 2, 3, 4, 5, 6, 7, 8. I'm impressed. Usually when I split the class in half, I don't get the same number in each group, but here we did. So when I add all of that up, what do we have? 4 plus 3 is 7, plus 5 is 12, 13, 14, 19, 20, 21, 33, 34, 35, 36. When I take 36 and divide it by 8, I get 4. I'm sorry. I said 4 and I didn't write it. I get 4 and a half. And again, the mean is not one of the data values. Does anybody notice that there's a significant difference between the two groups? And because there's a significant difference between the groups, if we go and compare the two groups, I think the only values that are really significantly different was group 1 had a 0 and group 2 had a 12. And I think what made the averages so different was just those single values. And so that gives us the idea that the mean, we say that the mean is not resistant. One extreme value, and by extreme, value. I mean, either really high or really low. Can significantly change it. And so when we say average, most people think of this measure of average. They look at taking the sum of the values and dividing by how many. But we're going to see that one single value can make the mean very different. Another example that might show that is if I took the ages of students in class. Let's change it from students in class to people in class. And so, again, is this, hopefully this isn't too personal a question for anybody. Do you guys mind giving me your ages? Is that all right?
Yes, that's
Okay.
fine.
I'll make up for it and throw my age in there too. So Debbie, how old are you?
22.
Joshua?
20.
Michaela?
19.
Connor?
18.
Robert?
20.
Michael?
25.
Zach? Jack K?
18.
Jackson?
18.
Oh, I gotta move this because it's on top of people. Gina?
I'm 46.
Whoa.
Colton?
19.
No, look at
Right.
all. I would have
you.
expected mid-20s. Zach B?
So kind.
Madeline?
21.
Demaya? Let's look in the chat. Ah. Zach B is 30. Let me add him. Janae?
19.
David?
18.
Chris?
28.
And Caitlin?
22.
Okay. Let me go back and share again. And I'm going to add myself to that group. Promise you won't make fun of me, guys.
Promise.
61.
You promise.
So if we look for the mean, we need to total those and divide by how many. And so is there anybody with a handy dandy calculating machine near them that can add those up for us?
424.
Okay. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And so when we take their 424 and divide it by 17, we get that the average age is about 24.9.
Mhm.
And I'm thinking, looking at that list of numbers, that looks kind of high for the people in there. And I think what makes that high is me. So if we take the total of just the students and divide by how many, our number will be 16. And if we take that 61 from the 424, we get 363. And now when I divide that by the 16, we get something more like 22.7. And doesn't that look more like what the class average is? And do you notice just one large value can bring that average up significantly? Yes? And so that's that general idea that the mean is not resistant. And so sometimes we don't use the mean because the mean can, one extreme value can alter it a lot. Let's say, for example, I own a business and everybody that works for me gets what, like minimum wage. What is minimum wage now? I know the state tried to add it to $15 an hour, but not everywhere. So what,
1180, I think.
1180. Okay, so I'll be generous and give everybody $12 an hour. And so if we take that, I'm going to just do a little bit of, and everybody gets 2 weeks vacation. So if I take that $12 an hour times 40-hour weeks times 50 weeks, I don't pay you for vacation. So let's say I have 12 employees that make $24,000. And then myself, the owner, I take home $100,000. If I look at the average salary, there would be 12 people who make that $24,000 and the one person who makes that $100,000 divided by 13. Which is 388,000 divided by 13. And so, oh Lord, it would help if I pressed the buttons. That makes it look like the average salary would round to about $30,000. Is the average salary really $30,000? Well, the mean is, but you notice how that one person raises it significantly. And so can everybody wrap their mind around when we say average, most people think mean, but sometimes the mean isn't really the best description of average because it can be altered by extreme values. Have I said that often enough? And because of that, we look at different measures of central tendency. And the next measure that we're going to look at is the median. Has anybody ever heard of the median before?
Yep.
What is it?
Isn't that when you like, it's just the middle number?
It's the middle number. What helps me remember that the median is the middle number is the other place I hear the word median is when I'm driving. You know how sometimes there's a median in the road and the median is right in the middle of the road?
Good one.
Median is the middle number. What's important though is before you find the median, the first thing you do is you order the data values. Doesn't matter if you go from highest to lowest or lowest to highest, you order the data value and then you find the middle value. And so if I go through and I look at, let's look at our number of, well, let's look at our ages. And so give me a second. Through the, whoops, I switched the wrong way. The magic of cut and paste. I'm going to move this data to the other page. Well, it's on top of the others. Let's try that again. It's still on top of the others. So let me erase
Close
this
enough.
and try it one more time. That looks better, right? Now it moved after I erased that, right? Story of my life, me and technology. So if I were to put us in order, what do we have? We have 1, 2, 3, 4 people who are 18. We have 1, 2, 3 people that are 19. We have 2 people that are 20. We have, well, I almost missed the one person who's 21. Sorry. We have 2 people that are 22. We have 1 person who's 25. We have 1 person who's 28. We have 1 person who looks like they're 25. And, oops, I forgot. Before that, we have 1 person who's 30. And then we'll add me. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And so counting in from both sides, we'd say that the median age is 20. And because we had an odd number of values, the median is the exact middle. If we were to get rid of me again, it's 18, 18, 3, 4, 3 19s, 2 20s, 21, 2 22s, 25, a 28, a 30, 46. If there's an even number of values, what we do is we take the total, we take the sum, pardon me, of the middle two, and divide by 2. It's like the average of the 2 in the middle. So that would be 20 plus 20 over 2, which would be 20. And so do you notice those random high values don't affect the median as much as the mean? So the median is more resistant. It's less affected by extreme values. And so it's used a lot for cases when We don't want to focus so much on those extreme values. One semester, I was teaching the statistics class, and rather than just pulling numbers out of the textbook, I kept trying to get real life data for the students. And so I wanted to look at the average income for different jobs, different careers. And when I kept looking it up online, all of the data that I looked at didn't give me the mean income, but rather it gave me the median income. And that makes a lot of sense, because if you look at any one job, extreme values could very much influence the average salary. If we look at something, let's say, I don't know, somebody, if we're looking for the mean income at some charitable organization, you've got volunteers, they get paid zero. Their salaries of zero would significantly lower the mean. And then if you look at a charitable organization, something like the Red Cross, where the director makes almost $1 million, that extremely high salary could also very much influence it. And so if we want to look at things that aren't as affected by the extreme values, a median is a good measure of central tendency. If I'm looking at the median from a list like this, it's not too hard to count in from the ends to find the middle. But if I want to try to find the median for a large data set, we sometimes talk about the position of the median. And the position of the median is given by n plus 1 over 2, where again, n is the sample size, or how many values we have. And so if I look at the example above, the examples above, over here, if I wanted to find the position of the median, there were 17 numbers. I'm going to add 1 and divide by 2, and that gives me 9. And so rather than counting in from the two ends, I could say that the median is the 9th number in the list. And that's what I did. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9th number in the list. Down here, if I looked for the position, when I take n plus 1 over 2, that would have been 16 plus 1 over 2, which would have given me 8.5. And so it's halfway between the 8th and 9th number. And so the position of the median tells me where the number is in the list, where the median is in my ordered list. Sometimes you're asked to find the median.
I have a question really quick.
Yeah.
So for the position median and how you wrote down it equals n plus 1 over, is that a 2 or a z?
That's a 2.
Okay, because I was like, wait, what does the z mean?
That's a 2. And I apologize. I guess we haven't used z very much as a variable. Before we go too much further, code to my crappy penmanship. If it looks like that, it's a 2. And in order to make sure it's different, I put a line through my z.
Okay, I was just making sure.
No, yeah, and it's good that you asked me to clarify because I know I'm really trying hard to use my world's best penmanship,
You're doing
but it's not very good. So sometimes we have to find the median from a frequency distribution. And so in order to find the median from a frequency distribution, I'm going to go back real quick and see if I can use the magic of cut and paste to recycle some data that we already had. And yeah, over here on the side, we've got this frequency distribution of our shoe sizes. Oh, that's no good. I missed the 14. We don't want to do that. Leave anybody out. That's better. And so when I look at the median from a frequency distribution, I first want to find the total frequency. Uh-oh. We didn't do something. I have to backtrack for a minute. Let's find the total frequency. And so if I add this up, 1, 2, 3, 4, 5, 6, 7, 8, and 5 is 13, 14, 15, 16, 17. I'm going to use that to find the position of the median. And so 17 plus 1 over 2 would be 9. And so we want to, we can do it in one of two ways. We can list the data until we get the 9th number in the list. So we could say, all right, I've got a 5, I've got 2 7s, I've got an 8, I've got 5 9s. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. And so this is the 9th number in the list. So we could say that the median is 9. Or we can make a cumulative frequency column. Which is like a running total of the frequencies. And so what do I mean by that? I'm going to go down here and draw a line and add cumulative frequency. And so one person has size 5 or smaller. And then what I do is I add the next number. 1 plus 0 is still 1. So only one person is 6 or smaller. Then I add the next number. 1 plus 2 is 3. 3 people are 7 or smaller. Then I add the next number. 3 plus 1 is 4. 4 people are 8 or smaller. And I keep adding on the frequencies to that point. And the median is the first value with a cumulative frequency that's greater than or equal to the position of the median. And so since my position was 9, where my cumulative frequency is 9, that tells me that my median is that group. Does that make sense, folks?
Yeah, but so when you say greater to or equal, then that's for if it's like odd and it is like in between, right?
Yeah, so let's say I'm gonna,
Or even.
for a minute, let's make pretend that instead of, and I'll change it back to what it is in a minute. Let's make pretend instead of 5 people wearing a size 9, 6 people did. And so I'd have a cumulative frequency of 10. That's the first one that's bigger than 9, so that would still be my median value. Does that make sense?
Yep.
Because everything between 4 and 10 would be 9. But we'll put it back to what it was originally. And as I was going through and doing this, I realized that I made a big mistake, and we forgot to look at finding the mean from a frequency distribution. So give me a second, and let's backtrack for just a minute and look at finding the mean from a frequency distribution. Does everybody have all of this already? I'm not hearing any complaints, so I'm going to add a page and go back to finding the mean from a frequency distribution. And to find the mean from a frequency distribution, I use a table. And so I'm going to paste in and use our shoe sizes again. The sizes would be my data values. The frequencies I'll call F. Now, if I asked you what the mean shoe size was for class, should I just add those numbers and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? I don't think so, because we didn't have 10 people in class. We had this added to 17. And so the first thing that I'm going to do is I'm going to total my frequencies. And that's going to be N. Second thing that I want to do is to take into consideration that only one person had a 5. But if 2 people had a size 7, wouldn't those 2 7s, 7 and 7 would add up to 14? And that would be 2 people. So the next thing I want to do is I want to go through and I want to create that extra column, which is the data value times its frequency. And so I'll call that X of N times F. So 5 times 1 is 5. 6 times 0 is 6. 7 times 2 is 14. 8 times 1 is 8. 9 times 5 is 45. 10 times 3 is 30. Then I get 0. 12 times 3 is 36. 113 would be 13. 114 would be 14. And then I want to total that column So I'm going to say that's the total of the data values times its frequency. So here, let's see, 5, 6, 7, 8, 9, and 8 is 17, and 5 is 22, 28, 29, 30, 31, 32, 33, 34, 35, 3, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16. Did anybody else get 165? Is anybody else adding those? And so we'll say the mean is the total of that product. I'm sorry, that's X again. Let me try that again. Divided by my sample size. So if I considered all 17 people, when I add up the sum of the shoe sizes is 165. And so I'll take that 165 and divide it by 17, and I'll get the average size was 9.7. And when I'm finding the average of a set of values that's in a frequency distribution, it doesn't make sense that I have to take into consideration that there were 5 of this size and 3 of this size and so on, if I want to include the sizes of all 17 people. So far, so good. Any questions? If there's time, after we look at the next 2 measures of central tendency, I'd like to show you how this is used to compute your grade point average, which is pretty cool. If we don't get to that today, we'll get to that next class. If those are all right, then the next measure of central tendency is the mode. And has anybody ever heard of the mode?
Yeah,
Yeah, what is it?
I can't remember.
Okay, it begins with MO. It's the value that occurs most often. It's the value with the highest frequency. If no values repeat, we can have a set with no mode. And if several values repeat, if several values have the same frequency, which is the highest, we can have more than one mode. So for examples, I'm going to do a little bit of flipping back and forth in our notes so far. If we look first at shoe sizes, what would the mode be? So if I go back to this data, my shoe sizes, I think the highest frequency we had was 5, and that occurred with a size 9. And so we would say that the mode for the shoe sizes is 9. If instead we look at our ages, and I think oh, did I go too far? Our ages, I'm going to cheat a little bit and look at when they're in order. I think it's a little bit easier to see. We have 4 18s, 3 19s, 2 20s. Yep, I think that the mode age is 18, right? There were more people who were 18 than any other age. If we look at the number of siblings for the class as a whole, is everybody all right if I flip back to the page that had the sibling data on it? I'm putting the two groups together. So putting the two groups together, there were 1, 2, 3 people with 4 siblings. There were 1, 2, 3, 4 people with 2 siblings. There were 2 people with 3 siblings. 2 with 1. What does it look like? The mode is 2 siblings? But if I look at the number of siblings for, let's say, just group 1, I'm going to go back. And if I just look at the number of siblings for group 1, do you see that, oh my heavens, 2 people had 1, 2 people had 2, 2 people had 4. And so do you notice how this data set has 3 modes? 1, 2, and 4. So is everybody comfortable with the mode?
Yep.
If so, then the last one that we'll look at for measure of central tendency is the mid-range. Oh, you know what? Before we do that, I want to go back a little bit. Can anybody think of an example in real life where mode would be most commonly used? We had said for something like an average salary, we might use the median. I think everybody's seen the mean used an awful lot, usually for your grades or something like that, the mean is used. Can anybody think of a place in real life where somebody might want to use the mode as their measure of average? Not hearing from anybody. Do you want to hear what my classic example is?
Yes.
Let's pretend I own a shoe store, all right? And in my shoe store, whenever I order, I want to keep into consideration when I order my shoes what the average size is. And so if I'm ordering average size shoe of my customers, do you think I would define that average as adding up all their sizes and dividing by the number of customers? Do you think I'd define that average by lining up all their feet and finding the middle of the list? Or do you think I'd define that by the size I sell most of?
The size you sell most of?
Yeah. And so do you see how in something like retail, saying my average customer is, what was our average shoe size? Size 9 makes more sense than saying the average is whatever I got adding and dividing, right? So that there are, many real life applications of that idea of mode. And I think that's a real cut and dry example. If I were in retail, my average customer would be the one that I sell the most of, right? So, and now that next one is the mid-range. And the mid-range is equal to the sum of the highest value and the lowest value divided by 2. It's as if I took my numbers and I put them on a number line. So if I look at our sizes, the lowest was 5, the highest was 14, and I wanted to know where's the middle of the line. And so for our shoe sizes, (14 plus 5 divided by 2 would be half of 19, would be 9.5. And that would be the middle of my number line. And one example where mid-range is used is if I was looking at weather data and I want the average temperature for a given day. For the average temperature on any given day, do you think they're going to take the temperature every hour and divide by 24? Do you think they're going to take the temperature every minute and divide by the number of minutes? No, what they're going to do is they're going to take the highest plus the lowest and divide it by 2. And so that's where you get some of that average data. So measures of central tendency, we have mean, median, mode, and mid-range. The mid-range is probably the easiest to find, high plus low over 2. But because that's probably most foreign to you, people have a hard time remembering that. So remember the mid-range is the middle of the range, high plus low over 2. I think we're just about out of time. So I am going to, if everybody's got this, stop sharing. I think a couple of people came in after I took attendance. A couple of people came in late. Let's see, Jackson, you were a couple minutes late. Who else came in late? Anybody else come in late? Looking, scrolling through, am I missing people? I don't see anybody else here. Hey, can I give you guys like a round of applause? I've noticed of all of my classes, I think this class has probably among the best attendance. And who would have thought that the 8 o'clock in the morning class had the best attendance? So thank you for caring enough to be here on a regular basis. I hope you're finding something useful out of attending class. Does anybody have any questions? Is there anything that I can do for anybody?
No, you're great.
Okay, you guys are great. We will see you on, our next class is Tuesday.
Yes.
Wow, we'll see you on, oh my God, Election Day. Survive it. Survive all of the news between now and then. What we should do is we should do a statistical analysis and count how many times we can see an ad on television where it's one candidate knocking the crap out of the other one, saying how bad they are, as opposed to the number of times where it's one candidate just saying how good he is and not how bad the other guy is, right?
Right.
If anybody else tired of those ads, oh my heavens.
Yeah.
Have a good one, folks. We'll
All
see
right,
you.
thank you. You too.
Okay.
Bye.
Bye. Zach, do you have any questions? Can I do anything for you? You okay? Demaya, any questions? Okay, your audio isn't working. Are you all right now? Can I do anything for you? Or are you good? Oh, the quiz it will not be due until I'm not going to assign it until Monday. I haven't written it yet. Okay? And if your audio isn't working, I know sometimes when I listen to Zoom meetings and webinars at work, my computer that I use at work doesn't have a speaker. You can, if you want to use up your battery, right? You can call in and do the audio on the phone and still be on the computer to watch the class. So just a passing thought if you ever feel that you really have to talk, okay? All right, you have a good one. Oh, you still typing? Oh, no. Okay, well, I'll promise I'll keep the chat open, okay? All right, have a good day.